Welcome back to the Introduction to Animation Nodes tutorial series. If you came here directly, you might want to start at the beginning. All the info and links are in the video description below. In this video, we will modify materials using animation nodes. Okay, I'm starting with an empty file and I'll just quickly throw together a scene that we can use for this tutorial. I'll add an icosphere and then in animation nodes down here, I will take a matrix distribute and then an object instancer. Let's create a 10 by 10, set to step, set to 2 by 2. This many instances of my icosphere, and then object matrix output. Take these, put them here. Okay, maybe bring this up. Okay, now let's animate this a little bit. What I like to do, a very quick and easy way to animate something is to use a vector wiggle node and then switch on the list feature so that we have this gives us a list of vectors, and we need this many vectors, and we need the animation time info for the evolution. And then when I hit spacebar, nothing's happening because I have to offset this matrix here. So matrix offset the location, maybe on the C-axis. No, I mean on the C-axis here. So I don't know, 2 and then 0.2 and plug this in here. So now when I play, they're all wiggling around a little bit on the X and the Y and a lot on the C because this is what I said here. Okay, so this is like a super fast way to just get something animated here. Now let's talk about materials. How about we want to shade these spheres here according to their C location. Now you can easily do this with a material setup. You don't really need animation nodes to do this, and I'll quickly show you how you can do it. So you just get the object info, which gives you the location. You take a vector separate XYZ of the location, and then you have a C value here, which is the height. And now animation nodes is moving the spheres, but this setup here, the material is actually changing the color. Now if you wanted to plug this into a color ramp, you could, for example, set this to blue and this to red. So the higher they are up, the more red they have in them. Sort of like a temperature display maybe. So you really don't need, for this very simple shading here, you really don't need animation nodes. But this being a beginner's tutorial, I want to show you how you can set the color or change materials using animation nodes. So how can we achieve this same or very similar result using animation nodes? So I'll take out the color here. All we really have now is this material with just a white color. So back to animation nodes here. And if you hit Shift A and you go to the material here, you have a bunch of different nodes. And the one that we're interested in is the material attribute output. And this is a very simple but quite powerful node. It allows you to change a material that you plug in here and set a new value to a certain attribute. And then it gives you another material. So we have the data type material. And how do we do this now? First of all, we used an object instancer to create copies of our icosphere. Now think of it, if you have a material, a single material on multiple objects, and if we change one input, one attribute like this, if I change this to purple, Now all of the spheres are purple. That's not what we want. It works here because the material gets basically executed for each object. But if we do this from animation nodes and we're just changing this one input, all we're doing is changing the color for all of the spheres. So we, just like what we did here with the object instancer, we have to create new materials in animation nodes. Okay, so we need to take a material instancer. Okay, we can start with a material. Let's take the one we have, the material 1. We want to instance this material this many times, and now we have a list of new materials. So each sphere now gets its own material. Just like what we did here, now we're also instancing the material. Now, how can we assign this? Of course, we need a loop. So if you don't know what a loop is, check the last video in this series. I'm just gonna hit Shift A, subprogram loop. That gives me this loop input. What do I want to plug into my loop? An object list and another iterator for a material list. W, create invoke node. And here I'm gonna plug in my object list and my material list. And that's all I need. Now inside of my loop, I will use this node. But first, let's get that C location, the elevation basically of the sphere. Of course, we do that by using an object transform input. Use the object, gives us a location. We can take a vector separate, which gives us the C value of that location. Now let's create a color. Why? Because this input socket here is a color data type. Okay, create a color. What can we do? There is a data type color somewhere. Right here. And we can choose combine separate. So we need to combine a color. Let's set the R value to be the C value. And now we can assign this material, or we can change this material that we're getting here from the list, and we can assign a new value to a certain property, an attribute here. And then we have to assign this material to the object. So we need a material object material output. We're going to assign this material to this object. How can I organize this? Like so maybe. And now all that's really left for us to do is plug in the right attribute in here. You might be thinking, well, you know that you have the input attribute node here, and you can take a name, a vertex group or a vertex color slot or something. You can plug that in here. But that's actually not how we use this in animation nodes. It has nothing to do with this attribute node. Instead, we're changing this attribute here directly. And how do we do this? Remember we changed, or we got the attribute key for the location or the rotation in one of the previous videos. Just right click and copy data path. Go back to animation nodes and paste it in here. And this is the attribute that animation nodes is now changing. So it's the node tree.nodes, the principled BSDF node of all the nodes in the node tree, and the inputs of that at index 0, which is of course the first input here on the inputs. And then we're changing the default value of that. So we're assigning a new value to that value, changing this material. Remember, each of the spheres now has its own material because we instanced the material just like we instanced our icosphere. And then this loop is assigning this new changed material based on the material 1 that we're starting with, and assigning this to our objects that are floating up and down. So let's see if this works. No, it doesn't. And that is because we're gonna have to deep copy our original object so that we also have individual mesh data that has its individual material assigned to it. And now we have this. So we're not doing this with this setup here. We're actually changing this input of each of the materials. You can see if I select one of these here, this one has material new 009, and this one has 29, and this one is 49. Okay, so we're creating a bunch of materials inside of animation nodes, changing these materials and assigning them to the objects. Now, of course, we're only changing the red channel. So when they're going up from in front view, everything above 0 is gonna go red, and everything else is just going black. What if we wanted these to be blue? Well, we could, for example, take that C information, take a number math node, set it to invert, take the C information and plug it into the blue channel. And now we have very blue, black in the middle, and red up on top. And of course you can play with math and everything in here to determine the color that you want. Notice here that we're picking a node called principled BSDF out of the nodes of the node tree. And this works because there's only one principled BSDF in our material, right? So on the icosphere, on the original material, we have this one principled BSDF node. And this node has a name. You can set the name over here. So if I call this crispy, and I'm still using the principled BSDF, you can see it still works. And that is because we have to tell animation nodes to actually remove and create new materials. We can do that by hitting this checkbox quick and then unselect it again. And if I hit play now, you can see nothing's happening because this node doesn't exist anymore. There is no node called principled BSDF anymore. So you can go in here, call it crispy. Now let's take the crispy node, and you can see it works again. So if you have multiple nodes in your material, just name the nodes and then pick out the attribute like this, and you can change basically anything that you can set in here, any input attribute, any socket that you can think of in a material node tree. You can access, you can read, and you can write using material attribute input or material attribute output nodes. So now this seems to be a bit complicated for the same thing basically that we had before, just using the shader. But of course, I hope you realize that this is a very powerful tool because now you can use all kinds of things in animation nodes with fall-offs and matrices and whatever you can think of, and change a material according to whatever you come up with in your animation nodes node tree. Okay, now to recap quickly, let's change this up maybe. What if I wanted this color ramp in here in my material, and I don't want to change this input socket, the base color of the principled node. Let me just make sure that I am on material 1, yes. What if I want to change this factor and I want this to go from, let's make a rainbow. I'm sure you know how to make a rainbow. You set this to red. You set that one to perfectly red. You use the hue saturation value and the far attribute, which goes around the color wheel the far way from red to red, and then you have a rainbow. So now we have a rainbow, and we want to change this factor using animation nodes. So right click, copy data path, go to layout, paste that in here. Now it says value has wrong type, and that is because we're plugging a color in here. Instead of the color, all we really need is the C value. Let's try that. So just a floating point, not a color. Let's reset our materials quickly. So switch this on and off and then hit play. And you can see we have rainbow colors for everything above 0 and basically just red for everything below 0. And that's of course because the shader here, this color ramp goes from 0 to 1. So you can surely think of something to plug in here to change the math around and fix this. For example, I'm gonna get rid of this combine color. Let's set this to absolute, which makes negative numbers positive. Plug that in here. And here we go. Now they're moving further down than just 1 unit. So you could even, for example, add another math node and multiply this by some factor. Whatever you can think of. And you just saw it's very easy to pick another node from the node tree and change other inputs just by copying the data path. And that is it. And of course, this works for all the node trees. I don't have any lights in this scene, so let's just plug a point light in here. So it works in Eevee and works in Cycles as well, because we're just changing our material node tree with this method. I hope you enjoyed this video, and if you have been following along from the start, I hope by now you have a good feel for animation nodes, how it is all set up, how things work in general, and that the huge amount of possible nodes is not that scary after all. If you have any questions, please write a comment below, and if you apply what you have learned here to create some awesome MoGraph or effect or artwork, please drop me a note with a link on one of my socials, so I can admire and share it. At this point, I want to suggest to you the many other more advanced free tutorials about animation nodes on my channel. Just check the links in the video description and my playlist here on YouTube. Please like the videos in the series and subscribe to my channel to let me know that you enjoy my content. You can download the blend files of this and many other tutorials from patreon.com/chrisp. As always, thanks for watching. Chris P out.